Morning. We're going to celebrate some communications from a student, and he's asked me a question, which is, why do things react chemically in the first place? So I'm going to try and take you through that. Bear in mind this is a sort of Key Stage 3, Key Stage 4 secondary version, so if you've got a PhD and you're picking holes in my theories and my teaching, give me a break. But I'm going to try and take you through some of the reasons why things react at all. Chemical reactions, they're everywhere. It's in the grass, it's in this chicken's stomach, it's me digesting my breakfast, it's this plant photosynthesizing, it's how things get made in industry. So it's pretty important to know that they exist, but also to understand why. Okay, we'll start with a little bit of history then. Obviously, chemistry and chemical reactions have always occurred ever since the Big Bang. We're looking at about 13.8 billion years ago. So that idea of a massive amount of heat and pressure causing things to collide, particles and atoms to collide to form elements, forming compounds, forming structure, forming matter. Okay, lots of things flying around, things forming. Like I said, 4.5 billion years ago, Earth came together, a lump of molten rock, minerals, and so it cooled, and the vapors of water condensed, and you got oceans and rivers. Then you got about 3.8 billion years, you got some photosynthetic organisms, and they start producing oxygen. So the atmosphere changed, got new stuff in it. And then people come along, they start building things, lots of pollutants, and there we are using chemistry to change the atmosphere of Earth. So let's strip it right back. We're going to go zooming into the size of particles now. So we're going to go right into the atom. So if you find an element of a single substance, you'd have an atom. And they'd all line up and they'd all be identical. That's how you know it's an element. Alright, that's the smallest thing we're going to be talking about today. Now some of these atoms are joined in elements, sometimes they're in compounds, so two or more different atoms joined together chemically. So again, this is over a story that started 14 billion years ago, but the stuff we see in 2020 are either elements, compounds, or molecules. So that is the stuff, the substance that the universe is made up of. So here your compound is the same element, but there's just two of them together and that's it. Walk around, O2, oxygen, very familiar with that one. So, for things to react together, first of all they've got to bump into each other, so they've got to have collisions. Now I got the red atom and I got the orange atom, and they could, in theory, at some point in the universe, have enough energy to be moving around, and then if they've got enough energy to move around, they may even collide, might smash into each other. Now, if there's not enough activation energy, or not enough kinetic energy in the pieces, for them to collide and form a new product, then that's fine, that's just no reaction. So that's what happens a lot of the time, you see that often. However, if you give a particle or an atom enough energy to collide, you may reach the activation energy, which means the enough energy for it to react. So you have a new product formed. So when you've got this new product, this red atom and the orange atom collided with enough force, they became chemically bonded. So there's a new product formed from the reactants. So again, this is what we see in the universe. Taken a long time, but most of those things that were going to react have reacted already. And then they've just sort of calmed down and relaxed in their place in the universe. I say I got this this red stuff here, these red atoms and these orange atoms. If I add them together, I collide them in an environment with enough activation energy. Maybe I heat them up, or maybe I add a catalyst. If I get them to react, first I've got to break them apart. So this all happens very, very quickly, but this is the model. So that red stuff breaks apart, orange stuff breaks apart, and then they recombine in a slightly different arrangement, and therefore again new products are formed. But I've got to give them the energy in order for them to do this. Okay, we're going to zoom in now to look at what is actually going on with these atoms and why they can collide and then stick to one another, why they rearrange and then something new is formed. So we're going to look at lithium to start with. So lithium as an atom is made up of protons, neutrons and electrons. You've got a proton number or atomic number of 3, you've got a mass of 7. Right, that's in the periodic table. So that's your proton number, that's how many protons you got. The 7 is the mass number. So if you've got a mass of 7, what's that made up of? Because we know for a fact we've got 3 protons, I just told you, and it is in the periodic table. So I've got 3 protons, but I've got a mass of 7. Now that means probably you've got protons. I've got 3 there, I've got 7, so I've got a difference of 4. Now the 4, the difference is the neutrons. So your mass difference between your proton number and your mass is made up by neutrons. So there I got the 3 protons, I got the 4 neutrons, gets me my mass of 7. So I got this mass of 7 with my lithium. So when I got my 3 protons, I've also got equal amount of electrons in an atom. So if any atom has got 5 protons, it's got 5 electrons. It's got 3 protons, it's got 3 electrons. So say we zoom into a nucleus of a lithium. You've got the 3 protons there, and then you've got a mass of 7, so I've got to have 4 other things in the nucleus, and they're your neutrons. So I've got 7 subatomic particles in the nucleus. Now I also got 3 protons, so I've got 3 electrons, and they live on electron shells that orbit around the nucleus. And you can see this one, lithium, he's got 2.1, so he's got 2 in this first shell, 1 in its outside shell. So I've got my 3 protons, and I got 3 electrons. So now we're going to look at what's going on here. So we've got these protons have got a charge of +1, so they've got a positive charge. Electrons have got a negative charge. So there's 3 positives and there's 3 negatives, so they sort of balance each other out. They have a neutral charge overall, but there's this one on its outside shell is the issue, and that's why we get reactivity. Now the thing that any element is trying to do is trying to get to a full outside shell. So this one on the outside wants to either be shared or it wants to migrate, it wants to disappear, it wants to go somewhere else. Because if I'm trying to get to 8, then it's really, really difficult for me to gain 7. I want to maybe just get rid of 1. Let's look at fluorine for a minute. Now fluorine is a group 7. It's quite reactive, very reactive in fact. So it's got 9 and 19 are your numbers. So your proton number is near 9. So you've got 9 protons. I got mass is 19. I'll work out the difference. It gives me a difference of 10. So I now got 10 neutrons. And because it's an atom that has not reacted yet, I know I'm going to have the same amount of protons as electrons, same amount of electrons as protons. So I know I got 9 there, so I'm going to have 9 there as well. Now again, the big secret here with why things react is that they're trying to get to 8. 8 is the magic number in terms of being a stable nucleus. Alright, so if we get 8 electrons in your outside shell, you are going to be stable. Now again, we said this, they do this by sharing, gaining or losing electrons. Now this is fluorine here, it's got quite a big nucleus, it's got 19 in the nucleus. You've got your 10 neutrons in green, you've got your 9 protons in red. And then you've got your electron shells. Now the first shell is filled up with 2. We've got to fit 9 on there altogether. So there's your 2. Then the next electron shell has got 7 in it. Now this is pretty close to our magic number of 8. Now the big game is to get to 8. This fluorine atom would love to get one more electron to stabilize the nucleus and have an outside shell of 8. That's all it's trying to do. So it's going to be very reactive until that happens. Now don't forget, lithium had 1 in its outside shell, would love to get rid of that 1 to go to its next full outside shell. So it makes up a great team. Lithium with 1 in its outside shell and fluorine with 7 in its outside shell. It would be great if they got close to each other in the wild, in nature. It would be quite an easy reaction to occur. Very easy, in fact. So that 1 electron in the outside shell of the lithium migrates, is lost to the fluorine outside shell. So now that fluorine outside shell becomes a fluoride ion. It's now got 8 in its outside shell, and it's got a negative charge. The lithium has got a positive charge because it's got rid of a negative electron. So now I got a fluorine ion, which is called a fluoride ion, with a negative charge. We know from old songs that positives attract, so you've got a positive charged ion of lithium and a negatively charged ion of fluoride, and they attract one another. So a lithium atom has lost an electron and there formed a positive charged ion. Fluorine has gained an electron and therefore formed a negatively charged ion, fluoride. Positives attract negative, negative attracts positive. They get held together by this electrostatic force, which allows them both to have full outside shells. So they hold together. So if I get lithium plus a fluorine, I end up with a lithium fluoride compound. So the whole question of why do things react in the first place is because they're trying to get to a stable outside electron shell. Now they do this by gaining and losing electrons, or with covalent substances sharing them. But all the time we're trying to get to 8. 8 is the magic number. So there you go. Hopefully you've learnt a little bit about chemical reactions, why they even happen in the first place. Remember that magic number is 8. So outside electrons trying to get to 8. And then once they do that, they stabilize. So many things over the history of the Earth have already reacted, and the familiar state that we see them in is because they are now stable, having reached that magic number of 8 electrons in their outside shell. They've done that by sharing, they've done that by gaining and losing electrons. So that's why it's all going on. When we see new reactions take place, it's because we're giving it new energy in order for it to react. So when we set fire to a match, or when we see a plant photosynthesize, it's because there's been a transfer or change of energy, allowing a new reaction to take place. Again, please subscribe, please like my videos, make some comments if you need to. If you want me to try and answer anything else, let me know, email me, or leave a comment and I will get back to you as best I can. Stay safe.